So if you're an architect or a designer, you already know that picking a wood species is really just step one. But here's the thing, and this is what trips so many people up on their exams. The real magic is all about how that wood is actually cut from the log. Today we're going to slice right into the three main sawing methods and see how they can tell completely different stories of grain, stability, and of course cost, all from the very same tree. Okay, let's get into it.
Okay, so check this out. Both of these samples, they're white oak. On the left, you've got that really classic wavy cathedral grain, and on the right, a super clean linear pinstripe. Now, imagine your design calls for one and you get the other. That could totally change the entire feel of your space. And this isn't just some random fluke, right? It's a direct result of how that wood was sawn. Understanding this is absolutely crucial for your design intent and, you guessed it, for acing those PPD and PDD exams.
So here's what we're going to cover. First, we'll get into the core idea of how one single log can tell three totally different stories. Then, we'll break down plain sawn, quarter sawn, and rift sawn one by one. And we'll wrap it all up with a head-to-head comparison that's perfect for exam cramming, plus a practical guide on how to specify these cuts like a total pro. So, how is this even possible, right? Well, it all boils down to one super simple geometric relationship: the angle of the saw blade against the log's growth rings. Believe it or not, that one thing controls pretty much everything: the grain pattern you see, how stable the wood will be, and, yep, how much it's going to cost. But first, let's clear up a quick but really important point. Okay, before we get any deeper, I need you to burn this into your memory. You are going to see the terms plain sawn and flat sawn, and they'll be used interchangeably, especially on your ARE exams. They are the exact same thing. Don't let that confuse you for a second. Got it? Awesome. All right, let's jump into our first method. This is the one you're going to see most often: plain sawn, or, as we just learned, flat sawn. And there's a good reason why this is the absolute workhorse of the lumber industry. The process here is, well, it's about as straightforward as it gets. Just picture a log at the sawmill. You just slice it from one side to the other in a series of parallel cuts. It's exactly like slicing a loaf of bread. The really key thing here is the angle. The saw blade is cutting the growth rings at a really shallow angle, somewhere between 0 and 30 degrees. This simple, super efficient method is what gives plain sawn wood all its unique characteristics. And this is where it gets really interesting. That shallow cutting angle, that's exactly why you get that famous cathedral grain. But here's the catch. That same cut, running almost parallel to the growth rings, means the board is going to expand and contract pretty unevenly when the humidity changes. And that's what causes it to cup and twist. So what's the big upside? Well, this method gives you the most usable lumber from a single log, which makes it the most affordable option out there, hands down. So, what's the bottom line here? It's all about picking the right tool for the job. Plain sawn is fantastic for projects where budget is king, for structural framing where no one's going to see it, or for general trim. But you got to be careful. You absolutely want to avoid it for things like wide plank flooring, especially over radiant heat, or for really precise casework where you need it to stay perfectly flat.
Okay, next up, we've got quarter sawn. With this method, you're sacrificing a little bit of efficiency to get a whole lot more stability and a much more refined, classic look.
You know, the name really gives it away. The log is literally sawn into 4 quarters to start. Then, each of those quarters gets turned and sawn perpendicular to the growth rings. So the cuts are kind of radiating out from the center of the log. And this completely changes the game. The blade's angle to the growth rings is now between 60 and 90 degrees. It's a lot more work, which, of course, has a big impact on how it performs and what it costs.
And wow, what a trade-off it is. By cutting across those growth rings, you get an incredibly stable board that just doesn't want to warp. The grain becomes really straight and linear. And for certain species, like oak, this radial cut slices through the wood's medullary rays, and that reveals these beautiful, shimmering figures called rayflex. It's that signature look you see in arts and crafts furniture. So, what's the catch? All that extra handling and waste means you get less wood out of the log, and the price tag goes up.
So this stuff is perfect for those high-end jobs where stability is everything. Think high-quality flooring, especially over radiant heat, fine furniture, and cabinetry. It's also the go-to choice when you want to show off those beautiful rayflex. So naturally, you'd probably steer clear of it for budget-driven projects, or if the design calls for a perfectly uniform grain without any flex at all.
And now, we arrived at the top of the mountain, rift sawn. This is the premium cut, really engineered for the ultimate stability and that super clean modern aesthetic.
Okay, so rift sawing is definitely the most complex of the bunch.
The log is still quartered, but then the cuts are made at this very specific off-axis angle, ideally right around 45 degrees. This precise angle is designed to do one thing really well: produce the straightest possible grain while actively avoiding the ray flex you get with quarter-sawn wood. But all that precision comes with a major trade-off. You get these big triangular chunks of waste.
What you get is a board that's just unbelievably stable. I mean, it's the best of the best. The grain is a perfectly straight, uniform pinstripe, which, as you can imagine, is highly sought after for minimalist and modern designs. But that perfection, it definitely comes at a price. All that triangular waste makes rift sawn the least efficient way to cut a log, and that makes it, by far, the most expensive option.
So when do you pull the trigger on something this premium? Well, it's really reserved for those high-end projects where the budget can handle it and the aesthetic absolutely demands it. Think premium flooring in a high-end retail space, minimalist custom cabinetry, or sleek trim where every single line has to be perfect. It's obviously the wrong choice for any project where cost or even just resource efficiency is a major concern.
All right, we've looked at all three. Now it's time for the main event, the showdown. Seriously, this is the part you're going to want to screenshot for your exam prep.
Let's break this down, nice and simple. First up, stability. Rift is the highest, no question. Then quarter, with plain being the least stable. Next, let's talk grain. Plain gives you those cathedrals. Quarter gives you straight lines with those cool ray flex, and rift gives you that perfect, clean pinstripe. And finally, yield and cost. Just notice the perfect inverse relationship here. Plain has the highest yield and the lowest cost, while rift has the lowest yield and the highest cost. It really is the perfect summary of all the trade-offs.
And if you're a visual person, check this out. If you don't remember anything else, just remember this cost hierarchy. Plain sawn, that's your baseline, $1 sign. Quarter sawn is a pretty big step up, $2 signs. And rift sawn, it's in a class all by itself at the top, $3 signs. Simple, clear, and really easy to remember when you're under pressure.
Okay, that's the theory. But how do you actually use this in the real world when you're writing your specifications to make sure you get exactly what you want on the job site?
All right, here's your super simple cheat sheet to lock this in for your exam. Just think of it in 3 short phrases. Number 1, plain is cheap, has that cathedral grain and it warps. Number 2, quarter is stable, straight with flex and mid-priced. And number 3, rift is the most stable, the most straight, and the most expensive. Just say that to yourself a few times and you'll have it down cold. Okay, pop quiz time. Your client wants a clean, minimalist look for their wood floors. Oh, and one more thing. The floors are going directly over a radiant heating system. So based on everything we've just covered, what cut do you specify?
And the answer is rift sawn. It's really the only choice that perfectly checks both boxes. It gives you the highest possible dimensional stability to handle those temperature swings from the radiant heat, and its perfectly uniform pinstripe grain delivers that clean, minimalist look the client wants. To make your spec totally airtight, you could even write rift sawn white oak, growth ring angle 30 to 60 degrees, no plain sawn boards permitted. Language like that ensures the mill knows there's no wiggle room.
So at the end of the day, remember this. That saw blade isn't just cutting wood, it's making a choice for efficiency, a choice for stability, or a choice for pure beauty. And as the architect, your specification is really the final chapter in that story. So the next time you choose wood for a project, just ask yourself, what story does this design need to tell? Thanks for joining me.